Hello, everybody. In this guided practice, we are replacing the old Boston housing dataset with the California housing dataset available through Scikit-learn. And students don't need to upload any CSV file the way that we did it before because we're going just to import it directly from Scikit-learn dataset. And the thing about this, you go to the Scikit-learn website and get that file for us. So there is not going to be a step for the CSV read in this case. So we're just going to download it, put it there. Something really cool is that we can actually import as a frame, and that will be already Panda frame file that will a lot easier for us in this case. Now, this is a unique occasion. Usually dataset doesn't come in any format. We need to work through the data in order to create the data frame per se. In this case, it's going to be array like that. So let's just proceed and move forward through this. So this is a new guided practice I just created for you guys. And you probably will see that it's a little different, but I just wanted to change the format a little bit. So hopefully it will be faster for you to understand a little bit and follow up the guide the way it's supposed to. In this area, we're going to be running every element. I just remove it a little bit the headlines on the top, but added more context to the actual code to try to understand exactly what we need to do. So I just want to keep a specific order in this case. I want to load all the libraries that we need in the beginning, Pandas, NumPy, Matplot, and Seaborn for, in reality, for the manipulation of the data and verify that everything is correctly, and then the Matplot and Seaborn for the actual plotting of that information so we can actually understand what it can have. But then after that, we're going to import the California housing dataset, the train test split, linear regression, evaluation metrics, and polynomial features as pipeline. And we're going to put all those through here because the target column is Methouse val, will represent the median values house. So let's start it. So first we need to import the fetch California housing from Scikit-learn dataset, and we can remove the to do now. Then from Scikit-learn model selection, we can do import the train test split. It's the one that will be used for do the 3070. For linear model, we need to import linear regression. And we need to import three different, the different metrics is going to come for R to score. We need the mean absolute error and mean square error. Oh. Then we need to import the polynomial features and pipeline. That will be polynomial features and pipeline. So that we have those, then we'll set an option for pandas that displays the max column as a none. So we just remove that section for the settings for the panda itself, and we just need to execute it. There's nothing that will be the output because we are not importing anything, but we'll see that it run. And after run with that check mark, we're good to go for the next phase. So before we train any model, we need to understand what the data set contains. We should never send data into a model blindly. We always need to verify, and that's what we're going to be doing in step number 2. And we should never send it blindly, as we said before. I'm going to verify the rows, columns, data types, missing values, and duplicate records. So let's do, we have importing the housing, create as frame equal true, because where we import this fetch California housing. And then we just need to do, our data frame will be our housing dot frame dot copy. So we have an extra copy, and that's the DF with the data frame that we're going to be executing. And in the end, we just need to print the head just to see what is actually came on the top. Let's try that. And yeah, we can see right here, we mentioned before, we had the column says median income, house age, average rooms, average bedrooms, population, average occupancy, latitude, longitude, median house value. So we have those particular data that we can utilize through there. So now that we have pretty much what we need there, we need to spec the dataset percent and print in the shape. And I think something that we're not doing before, don't remember who we did. So the really simple way to do print the shape, we use data frame dot shape. And that will come right there. And then we can just import the info for display the information from our dataset. We can see, okay, we have a shape of 20,000 values there. Okay, we have 9 different columns. It's 1, 2, 3, 4, 5, 6, 7, 8, and 9 columns, and 20,000 rows. That's where we can see the shape of our information. And our information tells us pretty much the columns names that we have across the board. And then we have the non-null, the count per se, and the data type for those. So that will help us understand a little bit we do. So we need to understand which one we need. So I think median income is one of the strongest predictions that we can use in a data set. And probably average rounds will be the other one. So connects the world for this chapter, room related variables through here. So the idea after that will, well, we need to check missing values in that particular data set. So we need to do a simple and missing values will be my data frame, as we mentioned in the video, is null dot sum, and that will print the missing values. And then we just need to duplicate the rows, and that will be very similar. We duplicate it, and then we just sum in order to have the total for those. Okay. Looks like we don't have any missing values, and we don't have any duplicate rows. So visualization helps us understand the data before we model it. So I think that's the correlation that we need to explore after this. It's important to just to see, okay, there's nothing missing. Okay, there's no duplicates either. So I think we can proceed with the correlation with the target. Help identify the features that might have a linear relationship with the target of the Methouse valve. So we can actually do that. Well, we talk about that in order to get a correlation, we can use core from the data frame, and we use numeric only true Methouse, and we just need to sort the values ascending equal false in order to have those correlations. So let's have those, and we can see it right here. Okay. The correlation for the Methouse ball is 1, and that will be the positive and the negative element. Let's actually plot this out in a matrix. I think that will be the best way to actually verify that. And we can see that particular correlation. So how can we actually explain this particular element? We can say the median income with median income has a 1-to-1 correlation, is the same value. So house age with house age has a 1. So this matrix will help us give you that diagonal of number 1, that we have that particular correlation, and then it will deviate upper or lower, depending the case, most colder or warmer, because we actually use those color warm map in order to understand how those actually need to be done. So here we can see that longitude with latitude, it was the farthest correlation itself, but we can see the average bedrooms with average room, it have a really near correlation in the one that we actually require here. We can see also the median income with the median house value has a really strong correlation here. So we can verify. So that will help us map it up which values could have a specific correlation across the board in the different elements that we need. So we need to select the fixtures and the target. So with here, I will say that median income with average room have a strong correlation. That could be one. Another target that I want to have is my median house value. Okay, that's the value that I want to predict. So in order to have that, I can see those through here. The average room with the median income will help me be there. So let's see if that actually pay off. So let's try it. Let's do Med Inc. And the next one is average rooms. And we define our target to be Met House Ball. And this is with an H. We try this. Okay, we can see that the definition is in there. X and Y are shape that we needed. Perfect. And we can see the X head a little bit just to see the first value. That's pretty much what we need. So let's start evaluate visualization feature relationship. So we need to evaluate those. When showing the R-square, MAE, and RMD, each metric is explained as the following, like R-squared, remember, tell us how much variation the model explains compared with the simple average baseline. Right? MAE will tell us the average absolute size of the errors, and RMSE will also measure the error, but larger mistakes are penalized more heavily. There's no single metric to actually tell us the whole story, right? Here we just we identify the data and we see how those actually work across the board. So we have most of the code already there. So let's do our med income with a data frame of med house ball. We can see that's pretty much the correlation that we have. We have some weird happening here on the top, but we can see somehow like a line where the group actually become with the median income and the house value. Less the income, uh, less the value, longer the median income, larger the value. So that's pretty much what we can actually see here in the plotting. So let's do a scatter plot for those, for the average room. So let's do average rooms regarding with our med house val. Oh, I didn't put those on quotes. And we can see, well, yeah, we can see it through there. The average room, this probably is a longer plot. We can make this a little shorter in order to define and see it better. We can see that the X is actually too much because we have some outliers probably here. I don't think there's a house with over 100 rooms, but look like our data set has those. So let's actually try to plot that out a little smaller. We can see if we need it, or in this case, we can see that we have some things a little weird, like a house with 60 rooms. Yeah, maybe not, but with over 100, yeah, we can see those through here, and we can work in a better way for that. So let's do actually split the data set into training a test set in this case, because I want to have it in a coefficients and predictions. And let's do a simple split of 73, the way that we actually need it. Let me just get back. Actually, let's probably change from average room. Let's verify if house edge. What's called house edge? Let me check. Uh, house edge. Yeah, here. Let's see if there's that correlation with house edge and verify how we can actually do it. So we can probably see a little better. So let's change this to house edge. Okay, so this will change to house edge, median house value. So there will be house edge, oops, versus median house. Let's try this. Okay, we can see those a little bit, those median values and how those correlate a little bit better. Could be understanding. So if we want to use house edge, we need to get back to defining here. So instead of average room, let's actually use house edge for our features here. Um, Actually house edge like this. And let's keep house value. Okay, X shape. Yeah, perfect. And let's try to move forward to the rest of the elements. So the idea here will be the splitting out. So we need to define the test size of the splitting, and we need to do a 30. So in order to have that, we do a simple as 0.30, because 100% is a 1. So 30% is 0.13. And we can try those to start training our model. Okay, yeah, because train will be 40,000, perfect. Test will be 6,000. And JTrain, JTest, perfect. I think those actually cool. So now we can start importing our linear model, and we did that as linear regression. And our linear model, what we need to do, we need to feed or train data. Right. Okay, just execute. So we have the model loaded. So the straight line is not always the best representation, but the example shows how polynomial regression can help us. Let's try to see that if that actually works the way. Let's show the straight line fit and the squares. Start making some predictions to verify if those actually do it. So we do linear model with predict for more egg test. And let's print those out. And we have the predictions right there. Okay. Let's evaluate. Like we can go manually and verify those make sense or not, or we can do evaluate with the square mean absolute and root mean square errors just to verify exactly if those actually working. So let's do R2 will be our R2 score that we import. There you go. Or may will be mean absolute error, and then NumPy with square rooting mean square error. We can see right there, the square is for 5, main 60, and RMC is 80 right there. So we can see that we are a little bit far of the prediction, but we can see that we're actually fail off or not that particular area. Let's verify with the prediction values. Let's plot that out and see if doing what it's supposed to. So we can see right here, those ones. Yeah, you can see where is that line of the prediction fall off. So it's really scattered out, but we can see that we are pretty much following just a little bit where the prediction came from in the linear regression, right? So let's try to intercept the coefficients. So we can do in that part. Let's do linear model dot intercept with the underscore at the end. And for feature coefficient in SIP X column linear model coefficient, we need to print it. Intercept is minus 10, media income, and house age. Those are the ones that will come up in the spec intercept and the coefficient for those particular models that we had through here. This output shows the intercept and the coefficient learned in that regression model. The intercept is the starting point of the equation, but in this simple example, it's not very meaningful by itself because it represents the prediction when both median income and house income are zero. So the coefficient when both are zero, we say that the cost value will be minus 10, dot 0, dot 10, very much, more or less. So in this case, the coefficient for median income of 432, 317 or 32 if you want to round that up. If the median income increases, the model predicts a higher median house value. Let's say we assume that the age stays the same. The coefficient for the house age is about 0.17, more or less, which means every additional year, the house ages slightly increase the predicted value. Again, assuming the median income stays the same. This number helps us understand the model equation a little bit, and that's what we can actually see through HOR. So let's predict one new value in those. So let's do column median income, and let's change this to house age. Oops. So let's do the linear model, predict house value. Let's see if it actually works. Is 2.16 in this particular case, showing us that that will be the median house value that we have in our scatter plot. Okay, so let's do that polynomial regression now. And the idea will be that we need to introduce a cover data set here so we can start seeing how it actually works. I think we can run this directly. So this is going to be our data set. It's just random numeric values. There's nothing related to anything, but we can see right there here how they are. So if we do a simple linear regression, remember we imported linear regression and we try to fit it. Let's see how it actually looks like. And the linear regression will try to do the best, right? It will very fast, afar from the first one. As long as it's going down, it's going nearest. It's pretty much going to be really, really near, but then it gets far again until it got up and then it just started. So we have just a couple of areas that this could predict a correct value. For most of the cases, those will be really out. And that's where the linear regression doesn't work. When we see that our data per se have a different curve. So for this particular element, we just need a polynomial regression in order to verify or to first see that particular one. So let's do degree 2 because we all have one curve here. And let's do linear regression will be for linear regression. Polynomial curve model, we need to fit the curve. I think we finished those. We can see then the plot side, how it looks like. And now our data endpoints and the polynomial degree, the two grades, is a lot better in this particular case. So now we can elevate or have better values in the prediction because it will follow a little bit how those data or scatter points move along or curved part. So we have multiple regressions on the California housing. Let's train our polymodel model. Let's do degree 2 in this case. And let's do the linear regression here. Optimal model, let's do fit, train, and let's do predict. And let's see how that goes. Okay. Let's evaluate it just to see if everything's doing what it's supposed to. So do the R2 score, the polynomial for the mean absolute error, and the NumPy square root for the mean square error. Let's try to see those. And we can see a little bit better numbers through here. Okay. Let's try to put those over there. And we can see that the linear regression, the squares a little bit better, may get there, and RMSE, it goes right where we can actually see it. It will help us identify that our polynomial regression is better, the errors are lower, the R square is a little bit bigger, but it's just for a really small amount. We can see it works a little bit better instead of linear, but we can see that it's just in that particular approach. So we can see that not every model is the same for or the evaluation will be the same across the board. You need to identify your data. You need to find which one will be a little bit better across the board. And then you just apply the correct evaluation in order to proceed. So I hope that you really like this. Did we get a practice? Did you want to provide me feedback? I'm open to. It's a little bit different than the other ones that we're doing so far. I want to see if you like to have a more help in the code blocks or you like the header a little bit bigger with the information that you require. So please let me know. Meanwhile, remember, any question, any doubt, don't hesitate to reach me. Happy coding, everybody.